Section 11.5b is about finding coordinates, specifically coordinates that are missing when you're using the distance formula. If you notice here, we have 2 points and we're given a distance between them, but we don't know one of the y values. So we're going to use our distance formula to solve that. So we'll plug the values in. Distance is 10. Now for the y's, for the x's, I'm going to take the 2 and subtract -6. Square that. And then because the order doesn't matter in this particular formula, I'm going to choose a minus -1. Now I'm also not going to rewrite this every single time, just so to save some time here, so see if you can understand that. Plus a negative, or minus a negative is the same as plus, so this becomes an 8 squared, which is 64. And then this becomes an a plus 1 squared. Now in previous chapters we've learned that that simplifies to be a perfect square trinomial. In this case, a squared plus 2a plus 1, and then we still have the plus 64. I'm going to combine these as like terms, so that's going to give me a squared plus 2a plus 65. We still have that under the square root, and that still equals 10. Now to solve for a, I have to eliminate this square root, so I'm going to square both sides. So we'll get 100 equals my trinomial. And then I'd like to get this equal to 0, so I can use the zero product property. So I'll subtract 100 from both sides. I'll come up here, and I will get a squared plus 2a minus 35 equals 0. Now I can factor this trinomial using the diamond. -35 on the top of the diamond with a 2 on the bottom. I need two factors of -35 that add to be 2, 7, and -5. So these will factor to a plus 7 and a minus 5. Zero product property says set each of them equal to 0 and solve. I'm going to get a -7 and a positive 5. Now what does that mean? That means those two values can be plugged in for my a here to give me points or ordered pairs that are 10 units away from this first one. Here's our second example using the distance formula to find a value that we do not know when we're given the distance. So I'll plug in the distance of square root of 274. My x's, I'm going to do 15 minus 0. And for my y's, I'm going to do a minus 4. Now again, I'm not going to rewrite every single step here. So 15 minus 0 is 15. 15 squared is 225. A minus 4 squared is a perfect square trinomial. A squared minus 8a plus 16. These are like terms, 225 plus 16. So my new trinomial is a squared minus 8a plus 241. The square root of all that equals the square root of 274. To get rid of the square root, I'll square both sides and cancel. So 274 equals my trinomial. My goal is to get one side equal to 0, so I will now subtract 274 and rewrite my trinomial up here as a squared minus 8a minus 33 equals 0. Now I can factor that. The diamond says -33 on the top with a -8 on the bottom. Two factors of -33 that add to be -8. How about -11 and 3? So we get a minus 11 and a plus 3, which means my two values for a will be positive 11 and -3.